Okay, so now we get to talk about chiral molecules. So this is kind of cool because it's kind of like these molecules are right-handed or left-handed. And so the definition of chiral is left hands and right hands are chiral because they are mirror images and they can't be superimposed on each other. Okay, so no matter how you change your hands, you can't superimpose them. So we're going to learn this and be able to identify the chiral and achiral carbon atoms in an organic molecule. And organic chemistry, when you think about it, it just means that everything's like carbon based, right? It's organic materials. Organic is basically carbon based. So don't I always freaked out about, oh my God, organic chemistry, kind of the same with biochemistry. It inherently, it's going to be a hard class. But if you break it down into individual little steps and what's going on, then it's not as overwhelming. So just organic chemistry is dealing with those organic molecules, mostly carbon, okay? So structural isomers. We talked about isomers way back when we were first starting to learn about the periodic table, okay? But molecules are structural isomers when they have the same molecular formula but different bonding arrangements. So for instance, here we have the same chemical formula, C2H6O, but if it's arranged like this, CH3, CH2, and then OH on the end, the hydroxyl group, then it's ethanol. But if we put the oxygen in the middle, it still has the chemical formulas the same. So if we do our equalization, we still have 2 carbons, it looks like 6 hydrogens, right, and 1 oxygen. I'm going to sneeze. Hold on a second. Sorry, I had to sneeze. Okay, but then if we rearrange it and put the oxygen in the middle, then it's going to be dimethyl ether, but the same chemical formula. So that's called a structural isomer. Same with C3H6O. If you arrange it this way, it's propanol, where if you arrange it this way, and again have the oxygen in the middle instead of on the outside, then it's propanone, okay? So moving a step further, we have stereoisomers. And stereoisomers have identical molecular formulas, and they are not structural isomers. These are atoms that are bonded in the same sequence, but they differ in the way that they are arranged in space. So when the mirror images of organic molecules cannot be completely matched, they are non-superimposable. And this is shortened to be chiral. Okay, so chiral. So not chiral, but chiral. So what is chirality? Well, chiral molecules, they have the same number of atoms, but they're arranged differently in space. And again, it's going to be the non-superimposable mirror image. Hands are like chiral molecules. They're mirror images and cannot be superimposed. So when the mirror images of molecules are identical and superimposable, then the molecules are achiral. Okay, so I know that's a mouthful, but we're good. Okay, so those are your definitions. So everyday objects, let's look at them as chiral and antichiral. So chiral, they can't be superimposed. Antichiral, or achiral, I'm sorry, they can. Achiral, they can be superimposed. Chiral, they cannot. So just kind of think as if it's a mirror image without flipping anything, then that's going to be like the achiral, where if they can't be mirror imaged without changing something, then that's going to be the chiral. So applying this to chemistry, so molecules are chiral when they have at least one or more chiral carbons, atoms, and a carbon atom is bonded to 4 different groups. So this is like when we talk about, remember how we made when we were talking about how many electrons make something happy? This is just like another thing. Carbons are happy when they have 4 bonds filled. So they have 4 binding spots, okay? And they always has to have 4 or else it's not going to be happy, okay? So a carbon atom is bonded to 4 different groups. And so it's non-superimposable mirror images. So let's look at a picture of this. So a mirror image of a chiral compound cannot be superimposed. So when stereoisomers cannot be superimposed, they're called enantiomers, okay? So here again we have a mirror. You can see that they look kind of like that. They look like they could be, but when you mirror them, they aren't. So you can see that these two aren't laid on top of each other, okay? So when the stereoisomers cannot be superimposed like this, they're called enantiomers. When mirror images of achiral structures are rotated and the structures can be aligned with each other, their mirror images are called superimposable. So this one, when we mirror it and we stack it, it is going to be the same because of the angles, etc. So if you look at like the other one versus this one, you can see that the molecule arrangement can't be superimposed, where this one, it can be superimposed. Okay, so let's do a little study check. So identify each of these as chiral or achiral compounds. Okay, pause me and come back. All right, so this one is chiral. Okay, this one is achiral. And then this one, dechiral. Right, great job, you guys.